on relationships between lines. Okay, so today it's much lighter than what we've been doing. A lot easier. Today you don't even need a calculator. You're just naming things. So we're gonna go over some new vocab things, new vocab relationships, words, and then use these for the next couple weeks. Okay. But the main idea is when you have a picture like that on the right, you have a line that's intersecting two or more lines, and it makes special relationships with your angles that are made. So the first thing we have to talk about, what is that line called that intersects two or more lines? Well, that's a transversal. So a transversal line goes through two or more other lines. So if we look at that picture here, which line would be considered our transversal?
T.
Yeah, here's line T. What two lines is it going through? Q and R. Yep, so line T. So when this happens, we have two different regions that are formed. We have interior and the exterior. Okay, so the interior would be this green part. So what angles do you guys see in there?
4 and 3. 4, 3, 5, 6.
4, 3, 5, 6. Those would be in your interior region. Angle 3, 4, 5, and 6. So now the region that's outside lines, Q and R, would be your exterior. What would those angles be?
1, 2, 7, and 8.
You guys are good. So that's pretty basic. But now from here, we actually have some special relationships that are made. And their names kind of tell you where they're located, okay? So consecutive interior, you guys know what consecutive means?
In a row.
In a row. So I want them to be in a row on the inside.
3, 4, and 5.
Yeah, so 4 and 5 would be one pair. Angle 4, angle 5. What would my other pair of consecutive interiors be?
3, 6.
Yes, angle 3 and 6. Consecutive interior. Now, alternate interior, we're going to be on opposite sides of our transversal, but on the inside, so in the green region. So like angle 4 and angle 6 would be a pair. Those would be alternate interior angles. What would my other pair be?
3 and 5.
3 and 5, yes. Okay, knowing that information, what do you suppose your alternate exterior angles would be? Alternate exterior.
1 and 7.
Yeah, 1 and 7 would be a pair. 1 and 7's a pair. What about, what's another one?
8, 2, and 8.
Woohoo! 8 and 2, 2 and 8, same thing. And then the last kind of relationship we have is corresponding, and they're just in matching spots. So do you guys see how we have like a group of 4 of angles right here and another group down here? So corresponding angles would be in the same location. So like angle 1 is in the top left corner. What's in the top left corner down here?
Angles 5.
Right? Do you guys see like top left, top left? So angle 1 and angle 5 would be corresponding. And we just like work our way around. So what would angle 2 match?
Angle 6.
Yeah, angle 2 and angle 6. 3 matches.
7.
Yep. And then 4 and
8.
That's it. So really, this is the heart of the lesson, just identifying our special angle pairs. I know it's a lot of information at once, but we'll use them a lot. It's just going to become second nature for what kind they are. So let's practice identifying these in a different kind of example. Okay. So what do you guys think 1 and 5 are here in this picture? Angles 1 and 5.
Alternate exterior.
They are alternate, or the inside
Exterior.
exterior. Yep, alternate exterior. And you can abbreviate I would probably always label it as that, alternate exterior. If you want to write the whole thing out, go for it. I just write too big for this board. What about 6 and 7?
Consecutive interior.
Yep, they're on the same side of your transversal on the inside of your line, so consecutive interior. Two and 4. Kind of goofy.
Corresponding.
Yeah, they're in matching spots. Top right corner, corresponding. And then 2 and 6.
Alternate interior.
Yep. Opposite sides of your transversal on the inside. Alternate interior. Now we're going to beef up our picture a little bit. Same idea, we're still naming them. We just have a more complicated picture. What do you guys think for 1 and 5? Yeah, and if you're kind of confused, do you guys see how 1 and 5 aren't on the bottom part at all? So cover it up. So now your picture looks like the one above. So those are corresponding. 2 and 11.
Alternate exterior.
Yeah, alternate exterior. That's good. Very good. 8 and 13. Alternate interior. Good. Okay, you guys try those bottom 6, and we'll go over them. Take your time. I will tell you there's.
Wait, is 8 and 13?
Oh, interior. My fault. Good call. Thanks for catching that. There is one no relationship out of those bottom 6, okay? Whereas this part would be the exterior.
Alternate exterior. Is this alternate exterior?
It's kind of
Alternate interior.
This is 2.
It is weird. Yep.
Oh, wait.
Yep. If it helps, take your hand and cover up half the picture you're not using. In one's a no relationship.
Oh, so
Interior.
I don't think it works though, because they're on different sides.
That's true. We didn't get any though.
I don't think that's it. Because they're not on the same level.
I just give some. No one doesn't want to think it's anything.
Yeah.
What do you do if it
It's kind of
Transversal.
Because these are just opposites.
Yeah.
It has to be the one that are like
Yep.
this way.
Yep. So that's the relationship.
Oh, we didn't get the balls. Kind of. I mean, like, you can't be like opposite.
What's 16?
You just can't do this and this.
That's this, I got it. Hey, 16.
But it isn't just like it's just not what it's on.
Yeah.
I'm not gonna
Not
either.
what it's on.
You're in judge. You are in judge. Oh, cheater, pumpkin eater.
All right, folks, check your first 3. Why is 11 and 7 no relationship? Does anyone know the real reason why?
No line can.
Yeah, we don't have a transversal line connecting them, so there's no relationship. So that's your no relationship. All right, check the bottom three.
I'm a genius.
Were we close?
Yes.
Good. Good.
And I aced it.
You aced it? I love that. That's great.
Except for, you know.
Okay, when you're ready, flip it over. We just have a few more things to talk about before we're done. We're not doing the whole page. We're almost done.
You guys always just be talking about exactly what the hell.
All right, folks. What do you know about parallel lines? Did you guys hear Silas? Because I couldn't. Silas, want to repeat yourself? They run adjacent to each other, right? And do they touch? No. Parallel lines do not intersect. And what's probably new for you is that these arrows on like a diagram, these pink arrows, that means they're parallel. That's what a picture would tell you they're parallel without saying it in the instructions. So in this example here, you could say JK.
Just kidding.
It's parallel. The shorthand for parallel is those two up and down lines to line LM. Make sure you put your little lines on top, otherwise it could be a segment. So JK is parallel to LM. Have you guys heard of skew lines before?
No.
No, I know, it's weird. So think of it like this. One's going up and down, and one's going side to side, but they're on opposite planes. So they're not parallel, but they can't touch.
So it's like.
So they're skew.
Cute.
But they can't be going the same direction. So they can't intersect, but they're not on the same plane. So that's why I think of it, one going up and down and one going side to side on separate planes. They can't be parallel. So in this example here, it'd be line L and line M. And we don't have a fun symbol for skew. It's just skew. Those would be our two skew lines. And then obviously parallel planes are also planes that do not intersect. You guys remember how to name a plane? Three non-collinear points, but in this picture here, how else can we name them? Yep, plane A and plane B. Those would be our examples. Okay, our last example here, folks, says use the figure below to answer the following. Name all segments parallel to TW. What would be one? UV's one. What's another one?
QR.
QR and? Perfect.
Yes.
You got them. Make sure you put your little segment bars on top. But there are three.
Quit talking to you. Mason, how do you feel about that?
I feel very good about that. I don't feel very good.
Okay, name all segments skewed to PT. PT. Now this is probably the most confusing example of the day. Remember, skew means one's going up and down and one's going side to side. So they can't be parallel, but they also can't touch.
QP
So
and
it'd be
WS.
like-
QP and WS.
Okay, so let's talk about QP. Does QP touch my red line?
Yeah.
So that doesn't work.
QR.
SR is a good one.
Yes, sir.
UV.
UV is a good one. WV's good. We're missing one. QR. Very good. We got them all. Okay, so WV, UV, SR, and QR.
Be honest.
Okay, and then our last example, give two examples of parallel planes. So I name a plane that they want to use.
TWU.
TWU. Okay, so this top plane would be parallel to what?
Yes.
There we go, the bottom. So that's one pair. Plane WVU and plane SRQ. Okay, I need one more pair.
TP and WVS.
TP, what was the third letter on that one?
U.
So that front plane. And then what's parallel to it?
WVS.
Yep, the back one. Perfect. Perfect. Good work, you guys.